Bench testing a 1959-1960 Cadillac headlight switch with the fog light option. Serial number HS06242024. Offered by TT Parts Rebuilding. Run-up test. Test number 1, tail and parking light operation. Test number 2, tail and headlight operation. Test number 3, tail and fog light operation. Front parking lights off. Test number 4, dash lights set low to high. Test number 5, dome courtesy light operation. Test number 6, circuit breaker test. Test number 7, switch terminals insulated from ground. Using a fully charged battery, right now we're reporting around 12.99 volts. During the run-up test, we're going to be boosting the battery. Now reporting about 14.22 volts. Also during the run-up test, we're going to monitor the rheostat temperature. To monitor the rheostat temperature, we have a digital meter here that's going to read the degrees in Fahrenheit. Test number 1, tail and parking light operation. First position, tail parking lights. I'm going to set the dash lights to mid-range. Back off. Again, first position, tail lights, front parking, and off. Test number 2, tail and headlight operation. First position, tail and parking. Second position, front parking lights are off, headlights are on. Back to first position, front parking lights are on, headlights are off, and off. Again, first position, tail, front parking lights are off, headlights are on. Back to first position, parking, tail, and off. Test number 3, tail and fog light operation. First position, we have our tail, front parking. We have an onboard shuttle switch here mounted to the front of the main switch. We rotate that. We shut off the front parking and turn on the fog. And off. Back to first position, rotate the front switch. Parking lights are on, fog lights, back to parking lights. In second position, this option is not available. Only in first position can we shuttle between the parking and the fog lights. Back to parking and off. Test number 4, dash lights set low to high. Right now we're monitoring rheostat temperature around 96 degrees Fahrenheit. First position, we rotate control knob and turn the front dash lights off. Slowly rotate that to mid-range. I'll let that sit in mid-range for a few minutes. See a slight increase of ambient rheostat temperature from ambient, about 97 degrees. I'll put that right about mid-range. It's about mid-range is about half the resistance of the rheostat. You can see the temperature climb. Right now we're about 100 degrees Fahrenheit. Let's go to full bright. Let's go to maximum bright, which is all the way to the stop. That is full bright. Now we're looking at around 101 degrees Fahrenheit. Let's go back to mid-range. Go to dim. Get this right on the maximum resistance just before they're off. It's at the end of the coil. We're hovering right around 101 degrees. And off. Let's go to second position, headlight position. We're mid-range on the dash lights. Monitoring around 102, 103. Let's go to dim. Back to first position. And off. Test number 5, dome courtesy light operation. First position, and rotate the rheostat, the control knob. We have indication of dome courtesy light by grounding the tab. Second position, I'm going to ground the tab with the switch body. We have indication of dome courtesy light. First position, dome courtesy light, and off. Features also available with the switch off, just by rotating control knob here and grounding the switch terminal tab. Test number 6, circuit breaker test. The Delco around the headlight switches had a built-in onboard bimetallic contact arm. It is a circuit breaker that controls the battery voltage to the switch. In an overheating situation, bimetallic contact arm will expand and break the circuit, protecting the switch and also the vehicle wiring. To demonstrate that, we're going to put it in first position, simulate the overheating of the contact arm, and we see that the battery connection to the switch is broken, protecting the switch and the vehicle wiring. Second position, that feature is also available. Simulate the expansion of the contact arm, and we see that the connection between the battery and the switch is broken, protecting the switch and the vehicle wiring. Back on, back to first position, expansion of the contact arm, disconnecting from the battery, and off. Test number 7, switch terminals insulated from ground. Using a standard 12-volt test light, we have continuity back to the battery at the switch chassis. And probe each one of the individual terminals on the switch body, demonstrate the switch terminals are insulated from ground. Here we have our dash light feed. See, there's no continuity back to the battery. Rheostat feed, no continuity back to the battery. Battery terminal, no continuity back to the battery. Headlight, no continuity back to the battery. Tail light, no continuity back to the battery. And parking lights, no continuity back to the battery. Dome light, no continuity back to the battery. Only at the switch chassis do we have continuity back to the battery. This demonstrates that the switch terminals are insulated from ground.